So if we look at number 17, the problem, if you look on your graph, it's written there. Remember, you're going to want some paper to write on because we have to do stuff to these to graph them. Okay. Is this in standard form? Standard form being that the biggest exponent is first, and then the next exponent down, and then the constant. It's not, is it? So let's write it in standard form. We want to put the x squared term first, which is negative 3x squared. We're always making sure we pull that sign with it. And then we have 7x next. And then we have, let's see, was it a minus? No, it was a plus 7x. And then a plus 2. There is a negative out in front of that x squared term. And if you remember, I mentioned this the other day, but most of these open up. But when there's a negative out front, we know this graph is going to open going down. That's what the negative out front does. It reflects. Make sure you make notes on this on your paper. It reflects the graph across the x-axis. Now, I'm going to kind of set up a graph over here to work on.
But what
How do you find the vertex of this graph? Remember the equation? The x-coordinate of the vertex, it's on your paper somewhere. The x-coordinate of the vertex is equal to negative b over 2a. That's actually the first thing on the top and the bottom of the quadratic formula. It's actually where it came from. Well, what's my b here? Let's find this. What's b here? This would be my a, negative 3. This would be my b, 7, and this would be my c, correct? If I label it ax squared plus bx plus c, just like we did with the quadratic formula. Remember how we just pull the coefficients off front? So let me go ahead and I'm going to make parentheses for them, and I'll plug the numbers in like green or something. Isn't the b positive 7? Y'all see that? And the a is what? Negative 3. Good. Okay. So this is just the x-coordinate of my vertex, but it is negative 7 over negative 6. Well, a negative over a negative makes a positive. This is not going to be a pretty graph, is it? I know that's the x-coordinate of my vertex. How am I going to find my y-coordinate? How do you find a y that goes with an x if you got an equation? Don't you plug the x in and then you can get the y that goes with it? Isn't that what we usually do if I have a x and I plug it in, I get the y out, right? Guys, if I have an equation and I plug the x in, can't I find the y from the equation? Okay, just making sure. All right, so y is negative 3 x squared, that's going to be 7 over 6 squared, plus 7 times 7 over 6, because x is 7 over 6, plus 2. Okay, so I have my vertex. It's not easy to graph. It's like, this is about 1 and a 6th, right, the x-coordinate, and my y value is around 6-ish. So if I want to graph that, x is 1 and a 6, it's just going to be slightly past 1, and 73 over 12 is about 6.08, so let me go up to 6. 1, 2, 3, 4, 5, 6. It's just a hair above 6 here. And you know what, guys? You can only be as accurate as you just try to be as accurate as you can, but I can't graph that very accurately, can I? If I got a point 1 and a 6 and 6.0833, there's no way I can just exactly graph that, so we just do our best. Just count over the x and then up the y. Okay, so I've got my vertex. I know this thing's going to open down, right? After I grab my vertex, I could sit here and plug numbers in, but that's not mostly, when you take your quiz, I'm going to ask you for certain key things, like what's the vertex? It would be this 7 over 6, 73 over 12, or whatever we had there. Now, what would be the next thing maybe that would be a good point to get? There's one point that's easy to get on here. What is it? What does this number on the end tell me?
2.
Well, it's 2. What does it mean? Where is it on the graph? That is my y-intercept. Okay, my y-intercept is 2. Actually, I could write that as a point. That point would be 0, 2. Or I can just go to the y-axis and color in 2. There's another point, right? Do you remember there's something about that vertex that is nice when I'm graphing? Does anybody remember what? There's something else about that vertex that I can put on here that might help me graph. Does anybody remember what it is? I'm going to start drawing it and see if you... It's called that. This purple line that I'm drawing is called the axis of symmetry. It's the vertical line that divides the graph into two symmetric pieces. The reason it's handy is that right now I can actually put another point on here. Since I just graphed that 2, if I think, okay, it's about this far over the axis of symmetry, that means about the same distance over here, I'm going to get another point. So I can draw that in, and now I've got, it's going to help guide my parabola a little bit better. When I draw it in, hey, the vertex was way up here, and there was a negative out front. It's supposed to open down. Is everything working out pretty well for me now? Does it look like my points are going down below that vertex? Vertex is right here. That line is the axis of symmetry. It splits the graph into two mirror images of each other. I could fold it across that line, and the points could match up. So far, so good, because if it's supposed to open down, the vertex would be a minimum or a maximum. Is that vertex going to be the highest point on my graph or my lowest point if it opens down?
Oh,
highest, yeah. It's like the red parabola up in the corner, isn't it? It's going to open down. So this point right here is going to be my maximum. Okay, so now, do you remember that the other thing I did was I tried to get the x-intercepts? All right, this is going to be a little tricky because if I want the x-intercepts, I need to look back at the equation, and I set y equal to 0, don't I? This is where I get a little confused when I'm working this. Now, and I guess it irritates me a little bit about this negative. If I wanted to get rid of that negative out front, couldn't I divide both sides by a negative or multiply both sides by a negative, and that would make it positive out front? If I want to try to factor this, can I factor with a negative out front? No, not very easily, right? So let me factor the negative out. If I factor a negative out, it just changes the signs on everything. That would be 3x squared minus 7x minus 2 equals 0. So now, if I want to try to factor this, I have negative 3x squared minus 7x minus 2 equals 0. So let's do this. Let's say, what do I multiply to get, okay, I'm going to multiply to get 3 times negative 2, which would be negative 6. Trying to multiply to get negative 6, and at the same time, the two numbers have to add up to negative 7. What would the numbers that would work be? I bet y'all know what they are already. Oh, is there anything that works?
Oh.
No, there's nothing that works. So what am I going to have to do? Quadratic formula. Ugh. Okay, so we can't factor this one, so we have to use the quadratic formula. I'm going to do that on the board, and we'll write our results here in a minute on the app. Okay, so let me get started. Okay, on the calculator, I'm sorry, on the board, we had gone and done the quadratic formula since it was hard to fit it on the iPad. So one of my zeros is negative 0.30, and the other one came out to be about 30. So these are just rounded numbers, but let me write them in here. I'll make them pop out. I'll make them like a green or something. So these are points on the graph, but 0.3, negative 0.30 would be about right, let's just say about right here. It's hard for me to get very accurate, but that'd be okay. That little green dot. 30 will be easier to graph. 1, 2, 3. It's going to be about like right here. My graph's not great. But all I got to do now to finish up is connect these dots. And I have my graph. We'll list the steps next. Okay, so let's make steps about how we know what to. I need to do the following things, not necessarily in the following order. Let me write out in general here. Here's my equation, right? So I need to graph some things on there, and I'm going for the things that are important about the graph. One of the most important things on the graph are the x-intercepts. You don't have to start with them, but let's just say I decided to start with find the x-intercepts. My two choices to find the x-intercepts are to to factor or to use the quadratic formula. And we always kind of hope we can factor it, but it didn't work out so well this time, did it? So I had to use the quadratic formula. I think the thing that y'all think is really difficult here is just the simplification. And the simplification, it's really just PEMDAS, and it's typing it in the calculator. So don't let that part throw you off. I just used the quadratic formula and I got some numbers, right? So that's one thing I got to do. And let me do them in color. Let me color code things. Let's say I've got a graph like this. Oops, don't want that. Oh, ignore the green line because you know it'll take me forever to erase it. Let's say that here's my axis, X and Y. Ignore this line right here. I'll just scribble it out. In green, let me mark in green, the x-intercepts are going to be this right here. They are the solutions to the equation that I get when I factor or I use the quadratic formula. My solutions are my x-intercepts. So when you solve it by factoring or you solve it with the quadratic formula, those answers that you get, x equal this and x equal this, those are your x-intercepts. So that's one thing you got to do. You don't have to necessarily do it in this order, though.
Will there always be two?
Not always, not always. Sometimes you'll just get one. For instance, if you had x minus 5 squared equals 0, and you square root both sides, you would have x minus 5 equals 0. And when you solve it, you get x equal 5 for both factors. So you can have that vertex sitting, like, let me come over here. I could have that vertex sitting on that line and it hitting like that, or it could even be facing up like that. So if it only hits the x-axis once, you'll only have one x-intercept, okay? Maybe we can do one like that in a minute. We'll see. Okay, now ignore that red. Let me just change colors here because I don't want y'all to... The second thing, or one of the other things I need to do, and this is always easy, is find the y-intercept. We found the x-intercepts. Now let's find the y-intercepts. That's the easy part. It's the c up here. It's the number on the end. If you solve for y, it's the number on the end. It's always just hanging out there, as long as you put it in this form. We'll learn something another time where it won't always be the number on the end because we'll change the way we write it. We're going to do some funky stuff with it. What was the other thing I did? What other point do I need to know? Like, okay, let me go back here. So that blue, the y-intercept in this case might be right here, correct? Now, unfortunately, the way I drew it, that looks like the vertex, but let's pretend it's not. Let's pretend the vertex, let me draw the vertex. Let's pretend the vertex is like actually right here next to it for some reason. It's just the way it works out. How do I find the vertex? Because that's my maximum or my minimum. Find the vertex. It's your maximum or your minimum. I'll just put min/max. How do I find that? What was the little formula I used to find that? Remember this formula? That gives me the x-coordinate, just the x-coordinate. Once I find x, what did I do to find y? I'm writing it down. What did I do? Didn't I stick it in the equation? I go back to the equation, I put that x value in, find the y value that goes with it, and that gives me my vertex. Let's do another problem so this makes more sense.